All right, so we're going to talk about solving a inequality, and we're going to start at the beginning and look at whether adding, subtracting, and multiplying and dividing will change a true statement to false, and if so, how do we deal with that? So we're going to take 26 and 39, and we're going to apply these different operations and see what we get. So first, let's add 7. So if we add 7, we get 33 is less than or equal to 46. Is that a true statement? It is. So we know that this is true. So we're going to try our next one. We're going to subtract 6. When we subtract 6, we get 20 is less than or equal to 33. Again, that is a true statement. So we know that both of these can work. So we get true statements. Now let's try multiplying. If we multiply 4, we'll get 104 is less than 4 times 9 is 36, carry the 3, 4 times 3 is 12, plus 3 is 156. We could easily double check this. So we have 39 times 4. Multiplying by hand still works, believe it or not. And is this a true statement? Well, yeah. So far, adding and subtracting created true statements. Multiplying by a positive number, it worked. So now let's try multiplying by a negative. So we're going to multiply by -2, multiply by -2, and what do we get? We get negative 52 is less than or equal to negative 78. Is this a true statement? No, it's not a true statement. Would you rather owe $52 or would you rather owe $78? Well, personally, I wouldn't want to owe anything, but if I had to owe one of the two, I'd rather be in the whole $52, which is a pretty good sign that that is the larger of the two numbers. So this ended up giving us a false statement, even though all the other ones gave us trues. So then, we're going to circle, pay attention to this one over here. We're going to divide by 13. I hear that's Taylor Swift's favorite number. Woohoo! So we're dividing by Taylor Swift, and we get 2 is less than or equal to 3. All right. So I guess applying Taylor Swift to this problem ends up with a true statement still. Let's try multiplying by the anti-Taylor Swift, -13. So dividing 26 by -13, and you get -2 is less than or equal to -3. Well, would you rather owe $2 or $3? I'd rather owe $2. So again, we get a false statement. So when we divided by a negative and when we multiplied by a negative, we got false statements, didn't we? Well, what are we going to do to make these statements true? What could we do? Well, the easiest thing to do would be to switch the signs. So if I divided by a negative and I switch the sign, do I end up with a true statement? I do. Let's try the multiplication problem. Oh, that's not what I meant to do. Oh well, green's fine. So we have 26 is less than or equal to 39. Let's multiply it by 4 again, or multiply by -2. And so you get negative 52 is less than or equal to negative 78. We said that was a false statement. Well, if you multiply by a negative and you switch the inequality sign, do you get a true statement? Let's see if that algorithm will work. Hopefully we can use a pen. Now do I get a true statement? I do. So our algorithm for solving linear inequalities is, it's exactly like a linear equality with one small difference. If I multiply or divide by a negative, I'm going to have to flip the inequality, and I will end up with a true statement. Now, these rules are all wonderful, except how do you use them? So here we have some problems. Let's take a look at our first problem. 12 is less than 7x minus 2. Now let's find what x is, and then let's graph it. Let's get wild and crazy, and we're going to graph this too. So we're going to solve this like any other equality. Let's get the x by itself. So what's the opposite of subtracting 2? Adding 2. So we're going to add 2 to both sides. And we get 14 is less than 7x. Great. So what is the opposite of multiplying x by 7? Dividing x by 7. So we're going to divide both sides by 7. And I get 2 is less than x. Well, let's go ahead and graph it. Now, since we only have one variable, we only have a number line graph. We don't need to do this on a 4-quadrant grid. And what I'm going to do is I'm going to put this solution that I got, 2, in the middle. And let's, for good measure, go one number on this side, one number on this side. Do you agree 2 is in between 1 and 3? Oh, okay. So let's go ahead and graph this. Now, you will remember that we have two different kinds of dots. We have closed dots, and we have open dots. Now, a closed dot means that the solution is where that dot is located. So that means a closed dot will have less than or equal to, or greater than or equal to, and open does not include the solution set. So we have these. So when 2 is less than x, we have an open dot because it cannot equal 2. And x has to be greater than 2. So that means x is going to be bigger than 2. So all of the numbers to the right of 2 should satisfy this inequality. Well, let's go ahead and try it. So let's plug in 3 and see if it works. So we have 12 is less than 7 times 3 minus 2. Well, what is 7 times 3? It's 21. So I rewrite everything else. 21 minus 2 is 19. So is 12 less than 19? It is. So we have made a true statement with a correct graph, with an open dot because 2 cannot be in the solution set. Let's try another one. Let's try number 10. Let's try this one. So we have 4x minus 17 is less than or equal to 31. So then, add 17, add 17. So we get 4x is less than or equal to 38. Divide by 4, divide by 4. So x is less than or equal to 9.5. So then, we make our number line. I'm going to put 9.5 in the middle. Let's put 10 here. Let's put 9 over here. And then, is this going to be an open or closed dot? Well, it's going to be a closed dot because 9.5 is in the solution set. And x can be anything that is less than 9.5. And so our graph goes that way. Let's do one more. Let's apply our new algorithm, shall we? Let's have negative 16x minus 12 is greater than, that's a 12, 14 minus 10x. So first thing I'm going to do is I'm going to add 10x to both sides. Plus 10x plus 10x. And so I get negative 6x minus 12 is greater than 14. Add 12, add 12. So I get negative 6x is greater than 26. So now I'm multiplying by a negative. I'm multiplying x by negative. So the opposite is dividing by negative. Divide by negative. And remember our new algorithm. When you divide by or multiply by negative, the sign will have to flip. So I get x is less than negative 4 1/3. So, for our number line, well, I'm going to put negative 4 1/3 here, and let's put negative 5 here, negative 4 here, and so x is going to have an open circle, and x has to be less than, and that's negative 5 is definitely less than negative 4 1/3. And let's double check it. I'm going to take this and plug it in and see what I get. So I have negative 16 times negative 5 minus 12. So I'm just going to do this half, or actually I should do it the right way. So I have negative 16 times 5 minus 12 is less than 14 minus 10 times 5. So negative 16 times 5 is going to be 5 times 6 is 30, carry the 3, 5 times 1, so that's 80, negative 80, minus 12 is less than 14 minus 50, 80, negative 80 minus negative 12 is negative 92, is greater than, and did this work out? So 36. So is that a true statement? And the answer is no, because I didn't put the negative here. Oops. So negative 16 times negative 5 is positive 80. It's always good to double check your work. Negative 10 times negative 5 is positive. Okay. So 80 minus 12. 80 minus 12 is 68. Is greater than 64. Is that a true statement? It is. So we know that this flipping around worked. So that is a quick review on how to solve a linear inequality.